I'm Anil Kumar. Welcome to my series on complex numbers. In this video, we'll discuss how to represent them in two dimensions. We call this Argand diagrams. So, in two dimensions, we have a coordinate plane which is very similar to what you normally see. The only thing is, on the horizontal x-axis, we represent the real numbers, and on the y-axis, we represent imaginary numbers, right? That's it. Now, we will be specifically looking into diagrams which form a circle. That is, the loci will be same distance away from the center, right? So that is what we are going to look into. We'll actually understand the meaning of absolute value of z minus z1 equals to r. So when I say z, it means a complex number, right? So whenever I say z, it will mean a plus bi, right? So that is what in general will be, right? z1 is given to us as another complex number. So this will be considered as a general point in our plane. So that will be a general point. And if I say z1, then that means I have a fixed point. Okay, so if I use subscript, that means we're talking about a particular point, right? For example, z1 could be equal to, as you can see in these examples, I'm saying 3 plus 4i, for example, right? So that is a fixed point. So that is one thing which we're talking about. And r will be the radii or radius of circle, right? So radius of the circle. So these are the terms which are being used. We'll actually discuss what is the meaning of z minus zi equals to r. Then we'll actually sketch the diagrams for these conditions. Loci of z, 3 units from origin. So when I say loci of z, that means all general points which are 3 units from origin. So basically it means that I could have also written this as the absolute value of z is equal to 3. So that translates to this. And it really means that we need to sketch all the set of points which are 3 units away from z. That means we'll look into this. What does that mean? Now, here's a general equation. Now, with reference to this, if you look into all other equations, things will become much more clearer. The next one is set of points z for z minus 5 equals to 4. And then we have z minus 3i equals to 5, z plus 3 minus 4i equals to 6. And then we have taken z with a negative sign just to complicate it a bit, but it doesn't really matter much. Anyway, let's begin with the meaning of what is this absolute value of z minus z1 equals to r, and then we'll look into rest of the questions. Okay, so as I was saying, we want to actually sketch all these you can say equations on complex plane, right? So when we say complex plane, we are saying that we have origin here, and this represents the real numbers. The vertical axis is a set of imaginary numbers, correct? Okay. Now, when we are saying we want to have, what does this mean? Distance, this means distance of z from z1 is equal to r. That's what it means, right? So basically it means that if I have a complex number z1, let's say here, so that is my complex number z1. In that case, if I take all the points from this which are r distance away, let's say r distance away, and let's say r distance away, right? And if I form a circle using this, it doesn't look like so nice, but I hope you get the concept. So what I'm trying to say here is that all these are units away, right? So the radius of this circle is r, right? So then what we are saying here is that the difference between any point, so if you check this out, let's say this is z for you, right? If this is z for you and that is the complex number z1, then r is equal to z minus z1, correct? So that's how it is. Well, let's try to prove it. Let's say this point here is let's say A. In general, let's take a point here, P. In that case, using the concepts of vectors, which complex numbers do represent, we can say that if I have to go from A to P, right? So if I have to go from A to P, what I could do is I could go from A to 0, right? And then from 0 to P, right? So then from 0 to P. So that is my A to P, right? Now, going from A to 0 is minus Z1, correct? And from O to P is Z, right? So now I could write this as Z minus Z1. And A to P is R for us, so that's how we get this equation. And since all distances are positive, we are always saying positive distances. So we put the absolute value. Does it make sense to you, right? So that is what it really means. Perfect. So if we have, let us say, a point Z1 as, let's call this as 3, 2, right? 3 plus 2i. So what I'm trying to say here is that we have a point which is 3 units here and 2 units up. So that point is, for me, representing Z1, which is 3 plus 2i, right? Now, if I say that the radius is, let's say, 6, right? This may, I mean, a bigger radius since I've crossed this here. And let us say if I have r of 6 units, in that case, any point on this circle, z, could be, what is the difference between z and this? Between z1 will be equal to 6, right? So any point on this circle where r equals to 6 could be represented like this, right? So from this discussion, you learn that z1 represents the center, right? So this point z1 is representing center and r is the radius. Correct? It'll be absolutely clear once we start taking examples, but I hope the concept is clear. So the distance of a point from z1 is r, right? Distance of any point from z1 is r. That is what it is. Okay. Now with that in mind, let's begin and sketch some graphs here. Now here, first statement is loci of z 3 units from origin. So this is a very simple and straightforward statement which says that we just want points which are exactly 3 units from origin, right? So that is our circle. And what we are saying here is that all these points are at a distance of 3 units. So this is 3, right? So this will be minus 3. And that is our plane, which is having real numbers on the x-axis, imaginary numbers here. So we could actually write this as the z is equal to 3. So that represents a circle, as you can see here. Now, if you compare with z minus z1 equals to r, you can see here that z1 is equal to origin. Correct? So the 0, that is the origin, right? And r is equal to 3. Does make sense, right? So that is how we straight away get our diagram, right? Next one here is that we have given a value of z1 as equal to 5, right? So now you need to sketch this set of points z for absolute value of z minus 5 equals to 4. Now, if you compare this with your equation z minus z1 equals to 4, we know this is the radius is 4, and the center you may write ER or RE depending on where you are, will be at z1, correct? So which is 5. So in this case z1 is 5, correct? So how will you sketch this? Okay, so we have a radius of 4, and we have to move z1, which is 5 units. Let's say this is 5 units, correct? In that case, our circle will be 4 units, so it will be shy with 1, right? So it will be kind of like this. Okay, so that makes sense, right? So this is all 4 units. I mean, sorry, 1, and 4 from here will give you 9. So what I'm trying to say here is that the radius r is 4 units, okay? And of course, this will be your imaginary axis, and this is your real axis. Perfect. So that is how you are going to sketch z minus 5 equals to 4. Now, our z1 is basically all real, 5, right? Another example here is, now we have taken z1 as minus 3i. Okay, remember this. We are always comparing with original equation. That helps to, standardize things and remember. So the center in this case will be what? Center will be 3i, right? And the radius r is 5, correct? So you can actually pause the video, sketch it, and then look into my suggestions. So 3i means what? Well, this is the imaginary axis, correct? And that's the real axis, real numbers. So 3, the center, is now going to be somewhere here. 3i, right? So this is at 3, 0, 3i, right? 3i. Now, and the radius is 5. So it is going to be, kind of like this. Okay, so 2 units it has to come there. So let me just sketch a bigger circle now since I've taken that. Okay, does that make sense? Okay, so that is it, where this radius here is 5 units. You get the idea, right? So, okay. So that is how you're going to sketch it. Perfect. So it's not very difficult. I hope you got the concept. Now let's look into next one here. So in this particular case, we have z1 as what? So let's rewrite this to understand the scenario. Now here we have plus, do you see that? Okay, e equals to 6. But we are always thinking about difference between the two. Perfect. So I have to rearrange this. So I'll write z, taking minus common, I'll get here minus 3 plus 4i equal to 6. Perfect. So that means the center is at z1, which is minus 3 plus 4i, right? And the radius is 6 units. Perfect. Now here, whenever we take 3 plus 4i, what is the magnitude of z1? Well, magnitude is square root of 3 square plus 4 square, which you know is 5. So 9 plus 16 square root, right? So as you can see here, we have shifted our center to a point on the left side. So it is minus 3, 4i, right? So we'll go 1, 2, 3. That is a minus 3, right? Minus 3. And then 4i means 1, 2, 3, 4, right? So that becomes 4i. Is that clear to you, right? So that becomes your center. Okay, so this is z1. Now, from here, we have to have a radius of 6, and this we know is 5. This we know is 5, right? So the radius will be 5 and 1, 6, okay? So kind of that much of radius, okay? So if you have to do a neater job, you can kind of make a scale here, okay, and then make a circle. Okay. So we have a circle, a big one this time. Okay, fine. So let's just close it. Okay, anyway. So if you are making on a graph paper, you can actually do a better job. So what I'm trying to say here is that this particular distance is 6 units. Perfect? And 6 units is more than 5, and therefore we kind of crossed and went to the other side. Okay? So this is your real axis, this is your imaginary, and that is your circle. So in short, this equation always represents set of points same distance from origin. Origin is represented by z1, and this loci is always a circle. Okay? Now here's the last question for you. You can actually pause the video, answer this out. Slightly tricky. Okay? So let's see how to work with this. You will see it is minus z here. So let's see how to work with this. We are given 3 plus 4i minus z equals to 5. We always want to keep that positive. So we'll take minus outside. So and rearrange. So we get z here, okay, and you get this as minus 3 minus 4i equals to 5. Now absolute value is negative is always positive, so I could write this as z minus 3 minus 4i. Clear? Equals to 5, and actually I should be writing as in terms of z minus z1 equals to r, right? That's the whole idea. So minus, if you factor it out, you get 3 plus 4i this time inside. Perfect, equals to 5. So here, the magnitude of z1, so z1 basically is 3 plus 4i, right? Magnitude of z1 is basically square root of 3 square plus 4 square, which we know is 5. And the radius r is also 5 units. So you can sketch this. So we have to go 3 and 4i. That means we are in quadrant 1. Okay. So we are somewhere here, 3 and 4i. So 3 and 4. Okay. Okay, let's say this point. And that is our radius, correct? That is our radius. So we can now make a circle with this radius and can go all around this. Okay, so that is what we are going to do. So that is how we are going to make our circle, and we know this circle has a radius of 5 units, and that is the z1, correct? So any point on this will actually represent z, and this position from here to there is our radius r, which in this case is equal to 5. Does it make sense to you? And this point here we found is 3 plus 4i. Is that clear to you? So that actually kind of summarizes what we have done in this particular video. So I hope the concepts are absolutely clear. Now let's review what we have learned in this particular video. So we actually began with understanding of our equation that the absolute value of z minus z1 is equal to r, where we found that z1 actually represents the center of circle and r is the radius. So in the given diagram which we have here, we are showing a set of points represented by z minus z1 equals to r. So in this particular case, what you should be sure of is that z1 actually is a position from here, right? So that is what is called z1 for us, right? And when we say z, that means any point on this circle. So there's a set of points which is this z, right? And r clearly is the distance between the two. Okay. So this is r for us. Perfect. So I hope it is absolutely clear. So from the center, you actually first represent the point with the help of your vector or z1, the complex number, and then from there, taking the radius, make a circle, and that circle will represent this particular complex number equation, which will always be a set of points in a circular way, same distance away from z1, right? So that is the loci of circle. Perfect. In the first example, which we took here, we are saying loci of z 3 units from origin, means from here all the points were 3 units. So center was at 3. So if you make a table for, let's say, center and the radius, so you'll realize that in this case the center was at 0, 0 and the radius was 3 units. In the second case, z equals to minus 5, here the center was at 5, 0 and the radius was at 4, right? So we're looking into this imaginary and real Rx, where this is the real axis and that is your imaginary axis, correct? For this, the center was at 0, 3i, correct? And the radius was 6 units. And here, the center was at 3 plus 4i. I mean, right, z equals to, I'm writing this as the z value, and the radii was 5 units, correct? So basically, this should have been written in the form z1 equals to a plus bi. I wrote in coordinate form, that's also okay, but that is what it is in short. So in this video, we actually learn how to draw a set of points same distance away from the given vector, where the distance is also given to us. Now in the next part, we'll look into inequalities involving similar equations. I hope you find it interesting and useful. Feel free to share my videos with your friends, and if you like and subscribe to them, that'd be great. And in case you have any queries, you can always send it to me on the email address shown on this sheet. Thanks a lot and all the best.